Hey everyone, it is Miss Lloyd here to drop some math knowledge. I'm pretty sure I just heard the collective roll of eyeballs of my students, but that's okay. I explained to them the other day that I'm super weird and they're eventually going to get over it, so it's all good up in this hood. Today we are looking at polynomials, and polynomials are algebraic expressions. Again, these videos that have the p point whatever with them is a prereq. So these are things my students should already know. I'm just reminding them because it's been a while and there's been the whole COVID thing and everyone's been stressed out. So this is just a reminder video. Fast forward through whatever you already know. That's totally fine. I'm not going to be offended. Probably won't even know if I'm being honest. Anyway, algebraic expressions. Those are what polynomials are. So we have a bunch of numbers with variables adding and subtracting together. Kind of looks like this. And so n is going to be the degree of the polynomial. So that's the highest exponent. So the largest exponent is going to tell you what degree that polynomial is. So when we have stuff like a quadratic, that's when we have an x squared, and then that's telling us that the largest exponent is a 2. If we have something like a cubic, that means our largest exponent is a 3, so it's an x cubed. And whatever number is in front of or multiplying with that variable with the largest degree, that is called our leading coefficient. So our leading coefficient is kind of like our line leader in this case. So this guy here, a sub n, because he has the highest exponent buddy, he is going to be the leading coefficient, so the coefficient that is in the lead. We also have our constant at the very end, and we know this is a constant because it's not multiplying with any variable. There's no x to any power there. I mean, you technically could say that it has like an x to the 0 power because that would just be 1 and it would make it go away. But this one just doesn't have a variable. So because it doesn't have a variable, it's always going to be the same no matter what. So it is constant. When we are adding and subtracting polynomials, so when we're putting two polynomials together, we want to group our like terms. And what I mean by like terms is that they have the same variables and the same exponents. So like I can only add an x squared to another x squared. I can only add an x to the fourth power to another x to the fourth power. If they have different exponents, like an x squared and an x cubed, I can't add them together. So once I've grouped them, I can actually combine them. So do the whole adding and subtracting thing. So combine those like terms. And I have to be sure that anytime there's a minus sign outside of parentheses, we have to do distribution of that minus sign. It is going to change everything. We're going to be subtracting every single term. And when we subtract a negative, it's going to change into a positive, like we're adding. So we want to be careful of that. So here's an example. I do have that minus sign there. We are subtracting. And so I'm going to see this as kind of a minus 1. So I'm subtracting a positive x squared. I'm subtracting negative 2, which means I'm adding. And I'm subtracting that negative 3 again, which means I'm adding. So I'm going to change all those signs. I'm going to look at which ones are my common ones. So which variables with the exponents do I see twice? So here I see a negative x and a plus 2x. So these are both x's to the first. Those are like terms, so I can add those together. I also have two constants, so two things without any variables. Here I notice that I have an x cubed and an x squared. Because they don't have the same variable or the same exponent, I can't combine them. They're just going to be left the same. I also like to put these in numerical order, highest exponent to lowest exponent. So I'm going to start with 2x cubed and put in that minus 2x squared. Next, I'm looking at my x's. So I have negative x plus 2x. So negative 1 plus 2 is going to give me a positive 1. So positive 1x, or just plus x. And then my 3 and 3 are going to add together to give me 6. I don't have any more like terms, so this is as far as I can go. Our next bit, whenever we're multiplying two binomials, or really it doesn't have to be binomials. It's also trinomials, so things with 3 terms, 4 terms, it really doesn't matter. So anytime we're multiplying, we got some parentheses there. I like to use the distribution method, which just means that I'm distributing each term from the first set into everything in the second. So the first term gets multiplied by the first and second term and the next set of parentheses, and so on and so forth. You could have also seen this as FOIL, so multiplying the first, multiplying the outsides, the insides, and the last. I don't like this one because it only works with binomials. The distribution method works with however many terms you have. So over here, I'm going to multiply or distribute in the 3x to the x, which will give me 3x squared. I'm also going to distribute or multiply that 3x in with the -5. So it goes to both of those terms. So 3x times -5 will give me -15x. I'm then going to distribute the -1 into both terms. So -1 times x is going to give me -1x. And I like to line them up according to what their like terms are going to be. So I know I already had an x, so I'm going to put the x's underneath each other, so then they're already grouped together and it's kind of like one less thought I have to have. And the -1 times the -5 will give us +5. Again, I don't have another constant. There's nothing else with just a number, so I just put that off to the side on its own. Now that they're kind of already grouped, I see that there's nothing with the 3x squared, so it doesn't have any like terms. The -15 minus 1 is going to give me -16x. And then there's nothing with my 5. It doesn't have another constant, so that's as far as I can go. So another thing, I'm going to do just this A part with you guys, and then I'm going to save some of these for my students. So one thing, we have this squared here, which means, say we have something like x squared. That means I'm multiplying the x with itself. So if we have something in parentheses squared, that means we are multiplying this thing in parentheses by itself. So we're using the FOIL or the distribution method on this. So I've got my x distributed in, which will give me x squared and 10x. I'm also distributing the 10 in. So I have another 10x. 10 times 10 gives me 100. Put it all together and what do you get? Again, I don't have any more like terms, so this is as far as I can go. I'm going to save this one for my students. And then I do want to do this word problem. So we have a square-shaped foundation. So I'm a very visual person. I have to have a visual of what it is I'm working with when it comes to word problems. I have to be able to see what's happening. So I automatically see square-shaped. I draw a square. So I've kind of already done this before and I just left the square there. And it tells me that I have a 100-foot side. So the original square foundation has 100-foot sides. So I know it would be 100 by 100. Squares are special because we have the same sides all the way around. Every single side is the same. So 100-foot sides, it tells me that one of the sides, so reduced by x feet on one side. So on one of these sides, I'm going to take my 100 and I'm going to subtract x. So it's being reduced by x. X amount of feet is being taken away. And then it says that it's being extended by x on an adjacent side. So the side that isn't being taken away is getting it added on. So this is going to be a plus x. Next, they want me to find the area in terms of x. So in order to find the area of a square, I'm multiplying the sides together. So it's the width times the length. So in this case, my width is x minus 100. Sorry, I wrote that wrong. 100 minus x. And my length is going to be 100 plus x. So when they want me to find the area in terms of x, that means that they want me to multiply all this together and simplify as much as possible. So that means I'm going to be doing some distribution. So 100 times 100, and also the 100 times the x. I'm also distributing in the negative x. I didn't order this right away, and so I do see, though, that my 100x minus 100x, those are going to cancel out. And so I'm going to end up with, and this is my area in terms of x. The last thing they want me to do is find the area if my x is equal to 7. So we now know what the x is, and I can plug that in to the x here. So then my area is going to be equal to 7 squared is 49. And so I'm doing my 10,000 minus 49. So I've got 9,951. They did tell me to begin with what my dimensions were in, what my units are, and that's in feet. So this is going to be feet squared for my area. Next thing I'm going to be looking at is factoring. And so factoring is when we're undoing the distribution process. So we just looked at putting some things together. We're now going to look at tearing them apart. One of the specials when it comes to factoring is the difference of squares. So we know this is the difference of squares because we have this minus sign in the middle. So difference, and the squares means that we could take the square root of both of the terms that are there. So it's always a binomial, they're subtracting, and we could take in our minds the square root of each. And so the square root of u squared would just be u, the square root of v squared would just be v. And the signs here are going to be opposite whenever we have their factors. So whenever we're tearing them apart. So if we had noticed at the previous example, this was a plus and a minus. So these are conjugates of each other. And when we multiplied them together, the middle term canceled out. We no longer had an x, we just had an x squared and the 100 squared. So then here the same thing happens. That middle term would have canceled out because those two signs are opposite. So we don't have a middle term, or in this case a uv term, because those opposite signs canceled out. We also have the sum or difference of cubes. So when we're working with two numbers that we know the cubed root of, either plus or minus, this works for either one. If we have plus, we'll use the formula in orange, so this one here. And this is a formula that I'm going to let my students keep. I don't know very many people who just do the sum or difference of cubes and need to factor that on a daily basis for their job. And even if they did, you could totally look up the formula. So this is a formula that I am going to give my students so they can just figure out which one it is and then just kind of plug it in. So if it's the minus, they'll be using this one. And so here we're going to do a few of these together. I have a binomial and I have a minus sign in the middle, so I know this is going to be a difference of squares. I also can imagine taking the square root of these. So those are difference of squares. And so the square root of 100 is 10. The square root of 4 is 2, and the square root of x squared is just x. And because this is difference of squares, I know I have two factors, two binomials this turns into. And because there's no middle term, I know I have a plus and a minus. And I always have students ask me like, oh, is it plus minus or is it minus plus? The order doesn't necessarily matter. It's the same as if you have 7 times 5 and then 5 times 7. Because they're multiplying together, the order doesn't matter and you're going to end up with the same thing either way. And so that's it. The biggest trick of this is just recognizing what it is and being able to pull it apart. They're all things that we already know how to do, like the square roots and whatnot. Our next bit, I do see a square and a minus sign in between. So then I'm going to try my difference of squares. So taking the square root, that means that would just cancel out. So my first term would just have the x minus 1. And then taking the square root here would be 3 and y. And this isn't the prettiest thing in the world, but honestly, it doesn't have to be gorgeous. It just has to be done. And so I have my x minus 1 again, and the 3y. And this one will have a plus sign in between, opposite signs. Again, doesn't have to be gorgeous, just has to be done. And the last one I'm going to go over here, I see a cubed, so I know I'm going to have to do the cubed root, but I look at 135, and I don't know the cubed root of that. That's not something that's pretty. But I do notice that each of these could be divisible by 5, so I'm going to take the 5 out. Doing a GCF, I'm going to put the 5 out in the front. Whenever I do that division, I end up with 27, which makes me happy because I do know the cube root of 27. So then, because I know the cube roots of these things, and I have a plus sign, then I know that I'm using this formula here. So then in this case, my u, or whatever the cubed root of this y would be, so u in this case would be equal to just y. The cubed root of y cubed is y. And then my v in this case would be the cubed root of 27, which is 3. And so I can just plug this into that formula above. So I would have my y plus 3. And then that's all I can really do from here. Another thing we're going to look at is factoring by grouping. So whenever we're factoring by grouping, this is when we have an even number that's more than 2. So an even number of terms is more than 2. Majority of the time it's going to be 4. So 4 terms, we're going to start by grouping the first 2 terms together and the last 2 terms. We don't want any signs in between. So we want to make sure that we capture any signs that are there. So that negative stays with that minus 5x. The next thing we want to do is take out the greatest common factor for each group. So I'm going to look at the first group and figure out what they have in common that I can take out. In this case, it's an x squared. So they both have an x in common, and the smallest exponent within that group is x squared. So I'm going to take an x squared out. When I do that, I would be left with an x plus x squared divided by x squared. Anything divided by itself, it's going to give you 1, unless it's 0, of course. The next group, they have a minus 5 in common that I can take out. So I'm going to put that minus 5 at the front. And then on the inside, the minus 5 would cancel out, so I just have an x. And then negative 5 divided by negative 5 would give me a positive 1. So here I notice that I have x plus 1 in common. So the next bit, it sounds complicated, but it's kind of what we already just did. Because I have one term here and one term there, these terms both have an x plus 1 in common. So I'm going to take the x plus 1 out like I would any other GCF, any other greatest common factor. When I do that, I'm just left with my x squared minus 5. And then this is our final product. Now, we don't multiply everything back again because we would undo what we just did. But once I separate and I see an x squared there, but I don't know the square root of 5, so I know I can't take this any further because it's not a difference of squares. I can only break that apart if I know the square root of both of those terms. I don't, so I'm done. When it comes to factoring trinomials, I do this thing that I have called M&A, the M&A method. So the M&A method, you start off by figuring out what multiplies to give you the product of your first term and your last term, or your leading coefficient and your constant. So in this case would just be negative 6. And what adds to give you the middle term. So in this case, it's going to be a positive 1. So the first thing I'm going to do is list out all the things that multiply to give me 6. So I know 1 and 6 and 2 and 3. These are the things that multiply to give me 6. Now I need to figure out how could I get a 1 out of any of these things. It doesn't matter what I do to 1 and 6. Whenever I'm adding or subtracting 1 and 6, I can't get 1. But I do know that if I had a positive 3 and a negative 2 and I added those together, they would add together to give me a positive 1. So negative 2 and positive 3 multiply to give me negative 6, and negative 2 and positive 3 add to give me a positive 1. So then what I'm doing here is I'm trying to figure out what added together to give me the 1x, and I'm going to undo that combining of like terms. So if we look kind of in the past a little bit, whenever I did my middle set, I had the negative 15x and the negative 1x in order to get that negative 16x. So basically, I'm breaking apart that step of combining those two like terms so that I can figure out what's going to go in these parentheses. So then here, I'm going to break apart my 1x into the negative 2x plus the 3x because I know those would simplify to give me a positive 1x. From here, I now have 4 terms, so I can group these the way that I did the factor by grouping. I have an x that I can take out of the first, and I have a 3 that I can take out of the second. I do have that common factor of x minus 2, and I would have left an x plus 3. And then I'm done. You can always distribute everything again to triple check your work, but this here is my final answer. Also, the more that my students do this, the more they might notice a trick. I'll reveal the trick in another video, but I'm hoping that they can find it themselves while we're in class together. Something to look out for. So the M&A method I find really helpful for when we have a number in the front. So our leading coefficient multiplied by our constant. We're looking at numbers that multiply to give us 6. So that 2 times 3, the leading coefficient times the constant, and adding to give us a negative 5. And so whenever I'm splitting up that center term, I call it splitting the middle. And the only time I really split the middle is when I have a leading coefficient other than 1. It's also helpful for my students when they first start using this method or when they first start factoring because it kind of helps them make sense if they're physically undoing that distribution process. So again, I'm going to look at the things that multiply to give me 6. And so looking at these, there are several ways that I could get 5. So I could, if I'm getting negative 5, have a positive 1 and a negative 6. So positive 1 minus 6 would add to give me negative 5. But it doesn't multiply to give me positive 6. Positive 1 times negative 6 would give me negative 6, so that doesn't work for the multiplying part. If I had a negative 2 and a negative 3, negative 2 plus negative 3 would add to give me negative 5. And negative 2 times negative 3 would multiply to give me positive 6, so this one works out. So I'm going to split my negative 5x into negative 2x minus 3x. Still have my plus 3 there, and then 2x squared. Now I can do my grouping, taking out a 2x from the first, and a negative 3 from the second, and I'm taking out a negative 3 here because I do want these inside parts to match. So if I started off with a positive x here on the inside, I want a positive x here as well. The only way to make that first term positive, since it's negative 3, is to take out a negative. So now my insides match. If they don't match, you want to go back and triple check that you've taken out what you can because those insides should match every time. Leaving us with a 2x minus 3 and an x minus 1. And then we're done. And so this is my video. I hope you guys learned some things. If you did, that is awesome. Please like, and if you know someone who you feel like could use this, please feel free to share it. Spread the love.